Okay, we are going to be learning to understand sum and products of functions. So just quickly, if we're looking at the sum and products of functions, we need to be thinking about the domain of a function. Of f is written as dom f. So for both of these functions, if we're thinking about the overlap of them, we need to be looking at what is the domain of both of them that are intersecting, and that would be our domain of our new function. So just in terms of how it's written, if we are adding or the sum, we are saying f plus g in brackets x. That's the same as me saying f of x plus g of x. Likewise, in terms of product, when we've got f, g next to each other, it means multiplying, like f of x times g of x. So let's look at this question here. It says given f of x is equal to square root of x minus 2, x is equal to or greater than 2, and we've got g of x is equal to square root of 4 minus x, where x is equal to or less than 4. We need to first look at what is the common domain of both of them. So that means we're looking at this area here on where they overlap, and we know, based on what we're told, that it's going to be between 2 and 4. The next thing we need to do is just need to add them together. So we're just going square root x minus 2 plus square root 4 minus x. We can't simplify that any further. So as I said before, another way we are able to write it, looking for the common domain, is saying dom f intersect dom d. So we're looking at where they both overlap. So sometimes it helps if we graph it to be able to see, or we can visualize it right here when we know they're both linear, so we know the domain is all real numbers. Then all we're going to be doing is adding functions together. So I'm adding f of x plus g of x. So this means I'm going x plus 1, and adding it to 3 minus 2x, I'm simplifying. So it's x, take away 2x is negative x, and 1 plus 3 is 4, so I've got negative x plus 4 for my graph. Okay, so let's look at adding terms. So when we're adding terms, the first thing we need to be doing is one, thinking about the common domain between square root x and g of x equals x. Well, one of the things we know is one is a line and one is a square root function. So how do they look? We can draw a picture if we need to, but we also know that our linear relationship is the domain is going to be all real numbers. So we need infinity to infinity, and we know a square root function is going to be to 0 all the way to positive infinity. If we add both functions together now, and we look at what's common, so we're only caring about between 0 and infinity. So I'm square root it. So I've got square root x plus x. Now I'm going to graph it. So when I graph, I need to think about I'm adding, and both my lines are above the curve in the positive area. They both are also starting at the origin. So at the origin, they're going to be equal, but then it's going to be above both the curves with what my graph looks like. So we can see here, I'll change the pointer. It's starting at 0. And based on this is a constant rate, and this one is from here. So then that means it's going to be going up higher and then going up here. So this is what my curve will be. If we look at this next one, there we go. f of x equals x squared, and then g of x equals square root x. Same thing needs to apply. We need to look at the common domain. We know with the domain of x squared, that is a parabola and it will be all real numbers, whereas square root x, we know it's just going to be 0 all the way through to the positive. It's going to rewrite this, but it's going to put on there because this should just be all real numbers for them. Now we know that we are wanting the intersect of both of them, so that would just be 0 to f. Now we are subtracting in this today, so it's the same process as we did before. We are just going to take away our function, so I'm just going to go x squared, take away square root x. It does help finding a few key points. So one of the key points I like to find is an x-intercept if we need it. So I can make y0 and solve for that. And I'm going to 1 of x, y will be 0. And then I can pick another spot, 2. At 2 will be 4 minus square root 2. That's just substituting it into my equation. Now at the moment, I'll change to laser pointer. So we are starting off with our quadratic, and we are taking this away. So it means at the start, we're going to be going under, and then at some point here, we're going to have more than what's been taken away. So at this point, we then start to get, oops, at this point here, we start to get as positive, and we go all the way up. So it's just about seeing the relationship here, that this means under to here, then we go above. These key points will come across a graph as well, and being able to place those points on. So I do encourage you to also find a couple of key points to help you, but you should be able to visualize on where the graph is going to be. So rules of addition of ordinates is if we've got f of x and g of x are positive, then they're both going to be greater than the previous graph of g of x and f of x. If they're negative, then going to be less than g of x, and they're going to be less than f of x. If one is positive and one is, if f of x is positive and g of x is negative, it means it's going to be between those two groups. Sketching the groups of f colon for all positive real numbers, union zeros, that means including 0, is described by real numbers. F of x is equal to square root x plus x squared. So again, we need to be thinking about the common ordinates. So with this, I'm just going to break it down in terms of 2. We've got square root x, and we've also got x squared. So that means square root x, we know the domain is 0 to infinity, and x squared, we know it's negatives infinity to infinity. So the same thing we are going to sketch. But before we do, we need to think about, are they positive? So square root x is positive, and we know x squared is also positive. So that means because they're both positive, it's going to be bigger than both of our graphs. Okay, so if I look at from just the two that we have, we know it's going to be starting at the origin, and we know it's going to be increasing, and it'll be going up here. We can work out a couple of key points. Which I've got here is 1 and 2, and 2 square root 2 plus 4 to help us graph it. The last one we are going to do is f is described by the domain -1 to infinity for all real numbers. F of x is equal to square root x plus 1 plus 2x. So we're going to split this into two graphs. We're going to be looking at square root x plus 1, and that would be the domain of -1 to infinity. And we're going to split it into a linear of 2x, and we know that it's negative infinity to infinity, or another way I would say it is all real numbers. Again, if I'm sketching, I'm going to quickly be looking at, are they positive in the y values, or are they negative? So the first graph will be positive, and the second graph is also going to be positive. If I'm going to look at graphing both of them, I'm just going to get my key points there, but I'm just going to put this here. So if we look at this at the moment, this is our what is common, and it's all the way through to here. If we think about our starting point, I'm just going to use the laser pen. Our starting point is this. So really it's a negative, and we're saying a negative plus 0 will be a negative. So our starting point will be here. Then it's going to increase more than this line. So it's going to increase, and it's going to keep increasing to this point.